On December 17, 1972, as the last crew to explore the moon lifted off the lunar surface, the commander, Gene Cernan, said, "We leave as we came, and God willing as we shall return, with peace and hope for all mankind." On January 14, 2004, the President of the United States shared a new vision for space exploration. This new vision includes completing the construction of the International Space Station and developing new spacecraft to carry astronauts back to the moon, this time to stay. The objective of this vision for space exploration is to create a roadway to the moon, which can provide benefits for all of humanity, a direct return on our national space investment, and a means to further human exploration to Mars and beyond. To develop the concepts and procedures to guide future explorers on long missions away from planet Earth, NASA's expanded a program that's been used to prepare astronauts for 6-month missions on board the International Space Station. Project NEEMO sends crews to a habitat on the floor of the Atlantic Ocean off of Key Largo, Florida. The latest mission, NEEMO 9, is to be the longest so far, and the first of these undersea missions dedicated to learning how to explore the surface of another world. This presentation highlights the objectives and challenges of this exciting mission to inner space in preparation for our renewed exploration of outer space.
NASA is embarking on all kinds of new missions, and one of them is the crew is not going to be breaking orbit for this. Instead, they're going to be going undersea. And here to explain what all of this is all about is Dr. Miran Anvari, and crew member and a friend of CTV News and CTV Newsnet today, astronaut Chris Hadfield. Good to see both of you. First of all, maybe Chris, you can explain to us, what is NEEMO 9 all about?
Well, we have to get astronauts ready for space flight through all of our different types of simulators, but it's really hard to recreate that sense of isolation, that sense of being totally responsible for your own safety. And we try it in our different simulators, but we found that one of the good ways to do it is to have what is a very similar type of environment underwater. It's almost like a piece of the space station. It's 20 meters underwater down off the coast of Florida, and we are sending a crew down there of astronauts and technicians for 2.5 weeks. We'll be staying underwater and working a lot of the science and medical advances that we need in order to go to the moon and to go to Mars.
Good morning, 8:14 on CH Morning Live. Very cool tech this morning on Morning Live. It's a groundbreaking project involving Hamilton's own McMaster University with NASA technology to develop state-of-the-art procedures for remote medical care. It is NEEMO 9. Yes, it's the 9th edition, and for the first time this morning, this is a real thrill. NASA astronauts Ron Guerin Jr. and Nicole Scott, thanks so much for joining us on CH Morning Live. Tell us about NEEMO.
Well, NEEMO is it's an exciting project. It's been going on for about the last 5 years, and really they are missions that take us into an extreme environment that parallels an environment like space and allows us to get experience in that environment so that we can develop the skills and protocols or practices for future exploration of space.
It's very hostile. It's an alien location on the seafloor, and the consequences of your training and your actions and what you do is very similar to spaceflight.
NASA brings their exploration objectives and expertise and uses that facility to really learn how we're going to go back to the moon and onto Mars, and how we're going to learn to live and work in space for long periods of time, and living in a small isolated habitat where you have to depend on your technical skills for the very air you breathe.
It's a technology accelerator. This particular mission is focused on exploration, and NEEMO is igniting the solid rocket boosters on our journey of exploration. We are taking off.
As we go forward with the vision for space exploration, sending humans back to the moon and on to Mars, we have to ask ourselves, do we have an analog that will help us prepare crew members for those missions? The best analog that we have is working underwater. We work collaboratively, NOAA, NASA participating together to enable astronauts to work underwater performing sea walks that are going to be very similar to the spacewalks that we're ultimately going to be performing on the surface of the moon or Mars. What type of spacesuits will we be using on the surface of the moon? What types of rovers will we use on the surface of the moon? Will the astronauts wear their life support system on their back, similar to what they did in the Apollo program, or will we use a different way of providing them with the air that they need to breathe? These are questions that we can get answers to, get data to help understand by using the underwater environment.
We're going to act as if we just landed on the surface of the moon. The first time we go outside of this underwater facility, it will be as if we just landed on the moon, and we are going to send out little robots to look, to inspect the outside of the ship, and then take very local little spacewalks, but the same idea, a scuba or of course tethered.
During NEEMO 9, we're concentrating on exploration objectives that are very unique, looking at sophisticated systems to be able to track the crew where they are when they're on the seafloor, to be able to communicate with the crew all the way from undersea back to the Mission Control Center in Houston with time delays incorporated.
Some of the other exploration objectives we'll be looking at is how to map different areas on another planet or the moon, and so we'll be going out in scuba and other equipment to do that, and we'll have some interesting equipment to support us.
And what's so great about the Aquarius facility is it really mimics a lunar base. I mean, when we go outside and we put our equipment on, we can give ourselves the same gravity that we would feel on the moon.
When we do our EVAs from the habitat, we're going to be treating them just like we would an EVA from a space station or a habitat on the moon or Mars. And in such that we'll be doing our equipment checkout. We'll be going through all of those, those kind of safety steps that you would to ensure you're going to be safe while you're out there, as well as having our topside team or our Mission Control Center working with us to ensure that those missions are successful.
But we also have rovers, remote operated vehicles. We have several, and those can be controlled either from the surface or from inside the habitat. Learning how to use a robotic helper is something that we're just learning how to do. And this is different from the robotics that you use on the space station or on the shuttle. This is a new type of robotics where you have a smaller robotic system that operates almost autonomously. These robots will have an arm, and so one of our objectives is to find ways of using these robots, figuring out what's the best way of putting those to work so that we get the most use out of them. And that's some of our objectives for this mission.
In the case of medical emergency, most people would go to a hospital for surgery. But if you were located in a remote region of the world, that wouldn't be possible. Now, thanks to the NEEMO mission, telesurgical applications can now extend beyond our world.
We're not going to have a hospital on the surface of the moon or Mars. So to solve the problem of delivering health care as we go forward and push the edge of the envelope in exploration, we need to develop these new technologies.
Okay, Dr. Williams, tell us what NEEMO 9 aims to demonstrate.
NEEMO 9 is going to be a really exciting mission. In NEEMO 7, we talked about telementoring, having a doctor direct another individual through performing a complex medical procedure. NEEMO 9, we're actually going to be doing remote telerobotic surgery. Having a surgeon located in Hamilton, Ontario, simulated patient will be thousands of kilometers away on an underwater habitat and seeing whether or not we can do this successfully.
And so they're going to actually be moving robotic sensors in Canada, and those are going to move the actual robotic forceps and surgical instruments down on the Aquarius habitat to perform a sample operation.
That type of telehealth technology can help us in routine medical care. It's also perfectly suited for disasters and disaster medicine, where we would deploy teams to the field, and whether it's in a disaster in North America or whether it's a disaster in another part of the globe, this capability that we're developing will truly change the face of healthcare.
We hope that we can demonstrate the importance and its effectiveness in providing medical and surgical care to a crew on long-term space travel to the moon or to Mars.
The hope is some of the experiments will help surgeons deal with satellite sound delays as they direct long-distance operations.
The wonderful people that make up the crew and being with them and just being immersed in that ocean environment on a pristine coral reef and being down there for 18 days, being able to wake up in the morning and look out the porthole and see the dawns and see the angelfish looking in at you, that's just going to be an amazing thing. So I'm really looking forward to that.
The way this mission is being set up, it really and truly is right in line with directly supporting NASA's exploration goals. And I think we have a real special opportunity to take advantage of and provide lessons learned that hopefully will have a positive impact and will provide value to the people that are developing the plans for going to the moon and onto Mars. And just living in this beautiful undersea environment and sharing it with some really fantastic crew members and all of us working together to make it a success.
I'm looking forward to not only, visiting a beautiful coral reef, but actually becoming a resident of that coral reef. I'm very much looking forward to the exploration activities and the development of exploration procedures that we're going to do. But I'm also looking forward to the telemedicine, not just for its exploration aspects, which are very significant, but also for its applications on Earth. For whatever reason, if an area of the Earth does not have access to a major medical center, any of those areas will benefit from the technology that we're developing.
I'm looking forward to living underwater. I'm going to have a much more profound understanding of life on our planet and appreciation of nature. It's a great opportunity that few people have. I'm very thankful to have that opportunity.